Good afternoon, everyone. I'm Lan Wu from Center for Autonomous Systems. My supervisors are Teresa and Alan. Today I'm going to talk about our work, Faithful Euclidean Distance Field from Log Gaussian Process Implicit Surfaces. In this work, we propose log GPS, a continuous and probabilistic mapping approach for multi-purposes suitable both for mapping and path planning. Autonomous robots in unknown and unstructured environments require accurate representations of the world. These representations can be used for different purposes such as localization, mapping, path planning, and manipulation. For instance, recovering a high-quality surface reconstruction for mapping purposes requires dense, accurate, and high-resolution representation. On the other hand, navigation purpose requires an accurate and efficient collision checking with distance and direction to the nearest obstacles for local or global path planning. It is difficult to recover a distance field directly, so the discrete and combination methods are often required to propagate the distance field through a grid. Our work proposed a unified representations that can directly infer both the implicit surface for mapping and the accurate EDF for navigation. Moreover, unlike most discrete approaches, our proposed representation is continuous and probabilistic. Inspired by the recently proposed heat method, it can simply solve the regularized Ankernal equation by applying the algorithm to a GPS with Maton covariance. By doing that, log GPS can infer the distance with gradients and the surface mesh directly, an implementation suitable for online inference that can be used for local path planning and robotic mapping. Only minor modifications to standard GPS. Those figures are the distance field comparison of 2D map dataset. It is evident that the EDF is linear and accurately predicted even far away from the surface measurements, and the surface is accurately predicted. This shows that our log GPS has the advantage of both mapping and distance accurate estimation. Here is our results and experiments. We separately benchmarked the EDF and the surface reconstruction with state-of-the-art mapping frameworks such as VoxBlocks proposed by ETH and the standard GPS mapping on both simulation and real-world data. For the EDF evaluation, we display the colored distance field on a horizontal slice. The EDF of log GPS is linear and accurately predicted with the lowest root mean square error. For the surface reconstruction evaluation, the mesh results for VoxBlocks and log GPS is equivalent, but ours can also provide uncertainty information. Our experiments show that log GPS produces the most accurate results for the EDF and the comparable results for surface reconstruction, and its computational time still allows online operations. Thank you for listening.